Now, let's look at the construction of a Heatrick exchanger. A Heatrick exchanger is constructed from flat metal plates into which fluid flow channels are chemically etched. These fluid flow channels are typically 2 mm wide and 1 mm deep semicircles. The plate layout and flow patterns for the cold and hot sides of the exchanger are designed to suit the particular duty. Each exchanger is uniquely designed to offer an optimized balance between the heat transfer, pressure drop, thermal effectiveness, and mechanical requirements. The etched plates are then stacked alternately, cold then hot, and diffusion bonded together. Diffusion bonding is a solid-state joining process where, under high temperature and pressure, grain growth takes place at the interface of two metal surfaces in contact with each other. The resulting bond achieves the same mechanical strength as the original material. The diffusion bonding process does not employ any braze, flux or gaskets in the construction of the heat exchanger core. This bonded core behaves as a single metal block with engineered holes running through it. It can then be machined and welded using conventional fabrication techniques. In order to achieve the performance, a number of blocks may be required. These individual blocks are then welded together to form an exchanger core of the required capacity. In order to confirm the absence of pressure between each block, an interblock vent is created in the block-to-block weld. Once the core is complete, headers, including prefabricated nozzles, are attached. These are half cylinders which distribute the fluids into the exchanger core. The exchanger is connected to the customer's process piping by way of nozzles. The nozzles can be designed to meet the customer's individual requirements and typically use flanges, compact hubs or weld preparations. Supports are then attached to the exchanger. The most widely used method is the N-type support. These are welded to the ends of the exchanger core. Alternatively, saddle-type supports can be fitted to the lower header of the exchanger. Lifting lugs are typically located at each end of the exchanger and are suitable for fitting with D-shackles for the attachment of lifting slings or chains. The lifting points can be incorporated into the N-type supports. Finally, the exchanger can be externally protected by painting or by sheathing with a corrosion-resistant material. This sheathing is a sheet metal cladding that is applied to the outer surface of stainless steel cores for enhanced protection in marine environments, typical of offshore installations. Heatrick exchangers are fabricated mainly from stainless steel, but can be made from other materials. Heatrick hold both an ASME U stamp and an ASME R stamp, and operate an integrated management system which is certified by Lloyd's Register and which encompasses ISO 9001, ISO 14002 and OSAS 18001.